In this video, we're going to discuss about augmented matrices. As per the definition, an augmented matrix for a system of equations is a matrix of numerical values in which each row represents the coefficients of the left-hand side of the equation and the constants on the right-hand side. Each column represents all the coefficients for a single variable. Let us consider a system of equation This can be written in an augmented matrix in the form So the use of augmented matrix is to solve the system of equations. So one of the method we can use is Gauss-Jordan elimination. To solve the above system of equations represented in A, which is U, written in the augmented matrix, we use elementary row operations. This can be interchanging two rows or multiplying a row by a constant or adding and multiplying a row with another row to convert it and to bring it into the form of So once we have the above augmented matrix in the form given in C, then we can get the value. We have the solutions for the system as x1 as p1, y as p2, and z as p3. Let us take a look at an example given over here. So have a system of equations given by 1. So writing it in the augmented matrix form, we get 3, 1, minus 2, 2, 1, minus 2, 1, 3, 2, minus 1, minus 3. So to solve it using the Gauss-Jordan method, we can use the elementary row operations. So as you can see, row 2 already has 1 in its x place. So what we can do, the first step would be interchanging row 1 with row 2. This would give rise to So now we have 1 on the top column. So now the next step would be eliminating the values in the column C2 and C3 here and here. So we need to bring a 0 over there. So for that we can perform a row operations as R2 would be 3R1, and for R3 we can use this would make it seven minus 5. So now we need to convert the 7 into 1. So this can be performed by using another row operation by multiplying with the constant the entire row R2 with 1 by 7 times R2. This would make it Now the next step would be converting 3 to 0. So for that we can use for R3 which makes it 1 minus 2 1 3 0 1 minus 5 by 7 minus 1 0 0 minus 20 by 7 and 0. Now we have the lower triangle, and now we can also perform another operation, R3 which makes it and now for row 1 we can use R1 minus R3, and for row 2 we can use R2 plus 5 7 R3. This would make it 1 is to 0 3 and for the final step R1 we can do R1 plus 2R2 which makes it 1 0 0 1 minus 1. So since we have it in this form, and from this we can obtain x as 1, y as minus 1 and z as 0, and this can be verified by using the values of x1 x y and z in the equation here, and we would get RHS. So using Jordan elimination we can solve a system of 3 equations, and this can also be applied to n-dimensional values as well, but it requires more work. So I hope this helps, and thank you.